Alrighty, welcome. So today we're going to be looking at applications of turning point quadratics. Now, one of the things that I'd really encourage you to do is whenever reading a worded question, step one, if it's a visual problem, draw something. There's no disadvantage in doing it. So Brett throws a ball at his cousin Lewis, who is 14 meters away. The ball follows a parabolic arc. This is where I'm going to use a bit of my intuition, right? It's going to look like that. The ball is not going to travel through the ground. You know, it's not doing this. So I'm going to immediately make the bold assumption that when it says a parabolic arc, I'm assuming that it's a concave down parabolic arc. If you've ever thrown something, you might have an idea of why I think that might be the case. Now it says reaching a maximum height 5 meters. 5 meters. Oh, sorry, it's 5 meters above the point of release from its hand. Refer to the function of p of x, where p is the height of the ball and x is the horizontal distance in meters from Brett's hand at the origin 0, 0. Okay, so let's change this a little bit. I'm just going to make it look a little bit more like a graph. So let's set up our axes, but use what we've got. Brett's over here. He's at the origin 0, 0. Well, if what's his name? Lewis is over here. He's going to be at the same height, which means that he's also going to be at 0. And this is going to be then 14, 0, because he's 14 away. So let's create a more proper looking graph and see what we get. Alrighty. And so you can see here, now I've just got to draw in the arc. Now, we know there's a turning point along here somewhere. It's at somewhere 5. Now, if you're thinking about it, you'd realize that if it starts at 0 and it lands at 14, it's symmetrical. Meaning the middle point should be exactly halfway between 0 and 14, which is 7. So the turning point is going to be right in the middle, and that's going to give us our shape. So this is going to be the point 7, 5, because the turning point has to be symmetric. So it's right in the middle. It's along the axis of symmetry. Well, if I wanted to work out a function and I knew the turning point, do you know what I'm going to use? The turning point form. So p of x, use the notation they've given, is equal to, let's just write out the turning point form. And I know what the turning point is. B comma c is then equal to 7 comma 5. So I already know 2 out of the 3 variables I'm looking for. X minus 7 squared plus 5. Now all I need to do is to find a. A is the only variable I don't have. But I've got 2 points to work with. I've either got 14, 0 or 0, 0. And I'm telling you 0, 0 is my favorite, so I'm going to sub in 0, 0. Another way you can think of it is that p of 0 is equal to 0. That's these things are equivalent statements. So 0 is equal to a 0 minus 7 squared plus 5. 0 is equal to a negative 7 squared is 49 plus 5. Subtract 5 from both sides. Divide both sides by 49. And I'm not going to work this out exactly. I'm going to leave it as a fraction, negative 5 over 49, which cannot be simplified. 49 is 7 times 7. 5 is a prime. No common factors. Okay, so there's my equation. My equation is going to be p of x is equal to negative 5 on 49, x minus 7 squared plus 5. So all done for part A. Now, one of the things that we can double check is, right, A should be negative. Why? Because this is a concave down shape. So it makes perfect sense that A needed to be negative because it should have been reflected, it shouldn't be concave up. Alrighty, so I've actually already done part C. In fact, I used part C to do part A. But last part is determine the domain and range. Once again, so much easier to do if you've got a graph. So the domain is normally in R, but as you can say, it makes no sense to follow the ball past the throw, meaning that we're going to be restricting the domain in between the throw and the catch. So for part B, the domain is going to be x is in between 0 and 14, or using range notation, using inequality notation, x is in between 0 and 14. For the range, we're also going to be restricting it into where the range ends up being. So it starts at 0 and only goes up to 5. So y is in 0 and 5, or you can write that as y is less than or equal to, is greater or equal to 0, less than or equal to 5. And there is your domain and your range, and part C is the graph, which I've already sketched perfectly. Alrighty, so that is an example of a worded question, and some of the strategies that you can go through to get a better grip on actually working through these problems and seeing what you can do with them. Alrighty, I'll see you in the next one. Goodbye.